Good day, everyone. Our topic is exploration of RIoT, the friendly OS for IoT. These are my team members, Dikshita Chalke and Yash Gavde, and I'm Junay Jain. So, what is IoT? IoT is basically Internet of Things that describes the network of physical objects, that is, things that are embedded with sensors, software, and other technologies for the use of connecting and exchanging data with other devices and systems over the internet. So, these devices range from ordinary household objects to sophisticated industry tools. So, with more than 7 billion objects today, or 7 billion connections of IoT today, it is expected to grow to 10 billion and 22 billion in 2025. So, what are the various software platforms for IoT? So, great expectations for IoT, but there are no standard platform yet to program most IoT devices. So, example you can see over here there is Arduino, but not it's not like Raspberry Pi, and there are other memories and everything given over here. So, what is RIoT? So, it is basically an open source OS specialized for IoT. So, RIoT enables developers familiar with POSIX or Linux to begin development for IoT devices with no learning curve. So, this coding enables newcomers to IoT and to begin coding quickly. So, RIoT has large independent development community and is distributed under an unclonable GNU lesser than General Public License or the GPL. So these two traits are similar and clonable to Linux. Hence, it is also called the Linux of Internet of Things or the LIoT.
Okay, so once we understand what our IoT OS is, we need a setup environment to develop application using our IoT OS. For setting up an R IoT OS environment, we recommend using a Linux and a Mac based system because the support of Microsoft Windows is under development. Getting started with our IoT OS on Linux, we first use Ubuntu version, and to create that development environment, we need to install the prerequisite before setting up the RIoT OS. So after the prerequisite are installed, as you can see, there are installments given available using Ubuntu. So these are the packets that have been installed, and sudo apt-get install consinal change. Okay. So after installing all the requirements, now we can set up the RIoT OS. For that, we need to create a work space folder for downloads and get git clone the latest release of RIoT OS. To do this, follow the steps. This is the code that we have to put in the RIoT using the git. So now it's time to set up the hardware tool chain depending on the hardware you want to use. Today, in our case, we use ESP8266 for demonstrating the RIoT OS example. For that, we need the tool chain. You need to create a folder name ESP. So after creating the hardware specific folder, now it's time to install and download the tool chain and cross compiler for ESP8266. Download the Extensa GCC compiler suite, that is the cross compiler. Now, after downloading the ESP8266 RIoT SDK, to use that, we need to set a environment variable. We need to set these two environment variables whenever we develop the base application. Number one is Extensa GCC compiler, and two is SP8266 RTOS SDK. After completing the installing of the toolchain, it is time to build an example. So we need to navigate our folder RIoT example hello world and set up the upper mentioned environment variables as you can see in the screenshot. Okay.
So in ROT, there is a system design in which we can see there are three modules such as threads, OS core, and hardware. In threads, there is an APP, NDN, and net device drivers which are connected each other by IPC. Okay, the NDN protocol is implemented as kernel thread the IPC channel is used for. In OS core, we can see the thread, IPC, and soft IRQ, and in hardware, it is CPU, timer, and net device. So passing NDN packets from and to the APP and network device driver threads, sending configuration commands such as example add faces, register prefixes. The currently implemented features that is basic packet forwarding logic, which is PIT, FIBCS, and support for Ethernet and 802.5415.4, which is the local, we can say something host of thing. Memory efficient packet encoding and decoding, and HMSC SHA 256 data signing and verification. So this is the application interface at the right side. We can see that the Indian code on RIoT OS is on C99 C99 is compatible. So in that we can see there are four objects, which is name, interest, data, and app handle. And this is a list of API for Indian app to on RIoT OS. So we can see the static Indian app where handling is equals to null, and these are the uh, JavaScript function. This is a simple Indian consumer on IoT OS. So the features of IoT, there is a security, connectivity, quality, and license. So security, IoT enables security IoT application. IoT supports DTLS transport layer security. IEEE 802.15.4 encryption, secure film firmware updates, suite, multiple cryptographic packages, and crypto secure elements. In the connectivity, IoT breaks silos. IoT is a modular to adapt to application needs. We need to support all common network technologies and internet standards. IoT is open to new developments and often an early adapter in networking. So in quality, the IoT is constantly tested, and the IoT community cares about code quality. Therefore, we use established tools such as MB unit testing and continuous integration, performing hardware in the loop, which is HIL, testing on multiple boards nightly. RIoT is free and open source. Most of the software development by the RIoT community is available under the terms of GNU LGPLUV 2.1, published by the Free Software Foundation. This ensures an open internet and allows for building blocks under different licenses. So conclusion. So RIoT, we can say RIoT is a developer friendly and a program as you are used to save time with common environments. Like there's a standard programming in C++, or standard tools, which is GCC and Valgridd. So zero learning curve for embedded programming, code mostly without hardware dependency. It is a resource friendly and IoT friendly. So in IoT friendly, it makes your application ready for the smaller things on the internet. So it is IoT is a basically Internet of Things, and the static and dynamic memory allocation, high resolution and long-term timers, tools and utilities, and automatic testing on various embedded hardware in the tool. So in this resource, it is like I have said that it is a resource friendly. So we can say that there is a real time capable of limiting interrupts, latency, which and the priority based scheduling. And this is a bibliography where we have done took our references from the following sites, from the Oracle and the from the RIoT. And thank you.